Hey guys, this is Mrs. Lyons. This video is going to walk you through molecular geometry. And when we say molecular geometry, what we really mean is the shape of atoms. And there's a theory that has guided determining the shape of atoms. It's called the Vesper theory. And the Vesper theory it's an acronym. It means valence shell electron pair repulsion theory. Now, if you just look at that as one big thing, it's like, what does that mean? But we can break it down. We know the valence shell is the outermost energy level. An electron pair is two electrons. So we're looking at electron pairs in the outermost energy level. Repulsion. Repulsion, when I think about repulsion, I think of, ooh, get away from me, you stink, or I don't want to be by you, something like that. Okay, so repulsion means push away or get away from, as far away. So this Vesper theory, what it's saying to us is that electron pairs in the outermost energy level want to be as far away from each other as they possibly can. Okay, and the shape of molecules is determined based on this theory. And this only applies to covalent compounds. When we get to ionic compounds in the next unit, we'll have a different way of looking at those. All right, so I'm going to walk you through the different shapes. Okay, and you will have a table on tests and quizzes that you can refer to. But basically, there are 5 shapes that you need to be familiar with. Trigonal planar is a shape that is when we just have 3 atoms attached to our central atom. Okay, no lone pairs of electrons. And this turns out to be, it's flat. It makes a flat molecule. And the atoms are spread as far as possible away from each other. All right, the second shape is very similar. Okay, it's called trigonal pyramidal. And this shape has 3 atoms attached, but also has a lone pair of electrons sitting on top of the central atom. And what this does is it kind of makes those hydrogens, it pushes them away. They are the whole repulsion idea, and it makes it kind of look like a tripod. Third shape is bent, and bent has 2 atoms and 2 pairs of electrons on the central atom. So again, those electrons sit up there on top of the oxygen, they kind of push down on the hydrogen, making this be a bent molecule. And then finally, tetrahedral. Tetrahedral has 4 atoms attached, no lone pairs. An example is CH4 or methane. All right, so when you're trying to figure out your molecular geometry, you're trying to figure out your shape, well, the first thing you have to do is you have to draw your molecule, okay? And then you're going to count the number of atoms attached to the central atom, and you're going to count the number of lone pairs on the central atom. And then you can use the chart on the back of your periodic table to figure out the shape or the molecular geometry. Okay, so here is an example, NBr3. All right, yes. Okay, so this is the correct Lewis structure for NBr3. Okay, so what you have to do is you have to look. You're looking at only things that are attached to the central atom. Okay, so how many atoms are attached to the central atom? We've got 3 bromine. And then on the nitrogen, we have a pair of electrons. All right, if you look at your chart, what you will see is that 3 atoms, 1 lone pair is trigonal pyramidal. Okay, and then bond polarity, we have to look back at our electronegativity table. And we're going to look at nitrogen is 3.0, bromine is 2.8, so that's a difference of only 0.2, so that ends up being a nonpolar bond. All right, let's do another one. H2O. All right, H2O has 2 atoms attached, 2 lone pairs. All right, when the electrons repel each other, the shape is actually going to be bent. Those electrons sit up on top of that oxygen. And then bond polarity, let's see, hydrogen is 2.1, oxygen is 3.5. So that's a difference of 1.4. So that means that that hydrogen-oxygen bond is going to be polar. All right, CH2O. All right, in this case, we have 3 things attached to the central atom. All right, now you want to be careful here because we want to know lone pairs, but we only care about the central atom. Okay, so these lone pairs on the oxygen we're not concerned with. So there are 0 lone pairs, okay, which makes this molecule trigonal planar. All right, and now if we look at the bond polarity between the carbon-hydrogen bond and the carbon-oxygen bond. So carbon is 2.5, hydrogen is 2.1, so that's a difference of 0.4. So the CH bond is nonpolar. And then we said carbon is 2.5, oxygen is 3.5, so that's a difference of 1, which puts that into the polar bond category. All right, one more, I think. So if we look at this, we have 2 atoms attached. Now, this is a place where people can make a mistake because they see this triple bond here and they count it as 3 things. Do not do that. This is a triple bond, but it's only attaching 1 atom, okay? So this only has 2 atoms attached. And then on our central atom, there are 0 lone pairs. So the shape of this molecule would be linear. Bond polarity, do you remember on the last slide we determined that carbon-hydrogen is nonpolar? And then phosphorus has an electronegativity of 2.2. Carbon is 2.5, so that's a difference of 0.3. So that would make the carbon-phosphorus bond nonpolar also. All right, so that is it for molecular geometry. I will go through and work out the homework and post those answers on the weekly preview. I hope this was helpful. Have a good day. I will see you in class.